Developing new technology requires the freedom to tinker, experiment, and explore. Southwest Research Institute's Internal Research and Development Program gives scientists and engineers the power and resources to do just that, to test and investigate. The program invests in unproven concepts, leading to impactful discoveries. More on the forward-looking program and the SWRI innovations it has brought to life, next on this episode of Technology Today. We live with technology, science, engineering, and the results of innovative research every day. Now, let's understand it better. You're listening to the Technology Today podcast, presented by Southwest Research Institute. From deep sea to deep space, we develop solutions to benefit humankind. Transcript and photos for this episode and all episodes are available at podcast.swri.org. Share the podcast and hit that subscribe button on your favorite podcast platform. Hello and welcome to Technology Today. I'm Lisa Pena. The SWRI Internal Research and Development Program allocates institute funds for project development beyond restrictions from contracts. It gives scientists and engineers the freedom and resources to figure out the best solution for a challenge, even if that means hitting some dead ends before finding the answer. In the spring 2024 issue of the Technology Today magazine, linked on this episode page, the IR&D program is described as SWRI's secret weapon. It's a fitting description. The IR&D program has yielded some incredible innovations from deep sea to deep space, many we have discussed here on the podcast. SWRI has invested more than $77 million in the last decade in internal research. Our guest today is SWRI Executive Vice President and COO Walt Downing. He has led the IR&D program as its administrator for 26 years now. Thank you for being here, Walt.
Thanks, Lisa. It's a pleasure to be here.
So the IR&D program provides funds to explore these unproven concepts and ideas. It offers this freedom of discovery. Really, it's a freedom to take a risk. So let's start with understanding why this program is so special and key to the Institute's success. What is the mission of the program?
Well, the mission of the program is to conduct proof of concept demonstration ideas for technologies that we want to try to pursue external funding. That's one of the principal reasons. Sort of a secondary reason is that it's a training ground for our staff to be able to conduct applied R&D programs for our clients, because we conduct these programs very much like our externally funded projects.
So the goal at the end of it all, it's not just about tinkering or messing around. There's a business development aspect to this. So there are important business goals at the end.
Yes, it's very formal from a proposal standpoint. It's like writing a proposal for an external client. You describe what you're going to do technically. You describe the budget and schedule. And an important aspect of the proposals is you further describe what you will do with the results of the project, particularly as you go out and try to do business development for clients in the future.
Okay, and it is a program with a rich history, so many success stories. We'll touch on a few of them today, but how did this IR&D program come about?
Well, it didn't exist from the earliest days of the Institute because, in those days there was little funding available to keep the operations going. But once the operations got stable, I think there's always been some degree of internal research. It was typically at the discretion of the executive officers, the president and the executive vice president. But in the 1980s, Dr. Norman Abramson was the executive vice president of the Institute, and he is the one that actually formalized the program, gave it policies and procedures, and established essentially a cadre of scientists and engineers that would serve as the administrators of the program or the coordinators of the program. And that's the start of our formal internal research program at the Institute as it exists today.
Okay, and so that's kind of the structure that's still in place today that
yes.
guides the program.
Yes, that's correct.
Okay, so let's talk about some of those success stories. That's the star of the program, the most exciting part. So really, there are so many success stories, as we've mentioned. So could you share a couple highlights with us?
Well, one of the things that we're very proud of is that many of our space instruments had their origins in internal research, or essentially the technology was matured through our internal research program. So I know in one of your previous podcasts you talked about the Europa Clipper, and that there's a mass spectrometer on that particular mission. There's a lot of internal research investment in that particular instrument, not only the instrument, but as well as the calibration facility that's been used to qualify that instrument. There's also a UV instrument on many of our space missions, and our heritage of UV instruments also has its origins in the internal research program. And the radiation instruments that we've developed, one on the space station and one on the Mars rover, had their origins in internal research. So you hear a lot about internal research in our space program, but it applies across our entire institution. Often we conduct internal research in concert with our consortia programs, such as our fuels and lubricants and powertrain consortia there. We use internal research as a way of providing a membership in the consortia as well, and so it also investigates parallel pathways to the technologies that our clients have tasked us to work on.
Okay, so space instruments to some of the technology that come out of our consortia. And I also wanted to touch on some of the projects that we've highlighted on the podcast that have their roots in our internal research funding. So our most recent was episode 66 with Dr. Kristen Ulmer. It was her research mission to Turkey in February 2023. That was after a devastating magnitude 7.8 earthquake. So she studied liquefaction, and her work will contribute to engineering safer foundations and buildings with the goal of saving lives during an earthquake. So really neat that came forth from internal funding.
Yes, in that particular situation, the professional society that Kristen belonged to provided the funds for travel and the living and the location, but didn't pay for her time. And so we have a category of internal research that we call staff renewal research, and that's what we use to fund her research on that particular effort in Turkey.
Also wanted to touch on Project Z, because that is a really standout project that was covered in episode 63 of the podcast. And Project Z is using our campus as a test ground for decarbonization technologies, including solar and hydrogen. So we're implementing emissions reducing solutions, again, right here on campus, because what we test and uncover here can be used on a larger scale to reach net zero greenhouse gas emissions by that critical target year of 2050. So your thoughts on Project Z?
So Project Z falls into a category of internal research that we call presidential discretion. And presidential discretion internal research projects are those that are really strategic in nature. So if you looked at the purpose of Project Z, it was twofold. One was to essentially make our campus essentially net zero carbon, and do that through renewable energies such as the solar technology or wind technology. And then also looking at how you might go about implementing various types of storage of that renewable energy so that it would be available when those natural resources were not available. So that would help the Institute, of course, with our electric bill and to be, of course, net zero. But it had the added benefit of positioning us to get further research for the Department of Energy as they look into these types of areas. So it would establish us as a potential site for test beds of technology, particularly the storage technologies in the future. So that's kind of the key about Project Z.
And on episode 57, we featured Enable, which is SWRI's markerless motion capture technology. So it captures and analyzes 3D motion with strategically placed cameras and powerful algorithms while eliminating the need for attached movement restricting sensors. So it has athletic, healthcare, and military applications, also has its roots in internal funding.
It does. And one of the things I think that's important to note about that particular project is that it was a multi-divisional project. We had our biomechanical experts in our mechanical engineering division, and we had our software and intelligent systems experts out of the intelligent systems divisions, and they work together because the key to making that technology work is developing models and having them execute in computer platforms. So that's another good purpose of internal research, is to help stimulate that interdivisional collaboration, which becomes, very innovative.
So many great projects. One of my favorite was featured on episode 48, and that is the SWRI Automated Shuttle. It's an automated 14-passenger shuttle deployed on our campus to test state-of-the-art self-driving capabilities, and it also doubles as a tour bus, which is neat. So this is science out of the lab and on the road, a great example of our internal funding in action.
It is. And that particular area of automated vehicles arose beginning in 2006 during the days of the DARPA Grand Challenges for Autonomous Technology. We had some staff members that were interested in competing in a DARPA challenge, and we discussed it and decided that wouldn't necessarily be the best approach. We provided test beds for some of the DARPA projects, and of course, the funding comes with strings attached, so to speak. And we decided it would be better to conduct our own research initiative program to get us into the autonomous vehicle technology area. So we established an initiative called MARTI, which is an acronym, Mobile Autonomous Robotic Technology Initiative. And it also had a nod to our former president, Martin Golan, so calling it MARTI. So that was a very large investment over many years, of over $4 million, to essentially help us develop the various autonomous technologies necessary to go into platforms. And we had a goal in mind that we started in 2006, and we wanted to enter a vehicle into the competition in New York City of the Intelligent Transportation System World Congress. And so in 18 months, after a lot of work, we actually successfully demonstrated our first autonomous vehicle at that symposium. And it's important to note, if you're in San Antonio, the San Antonio Museum of Science and Technology, SAMSAT we call it, has that vehicle. So we actually have a example of our internal research programs on display in a museum for our STEM students here in San Antonio.
All right, where it all started. That's neat for everyone to be able to see that. And I like that you said, this started in 2006, and here we are in 2024 still seeing the fruits of that funding.
Yeah, it's a very successful program.
Over almost a couple decades now. So, we've just covered a few of these really amazing technologies, but is there one that started as an IR&D project that you are most proud of? Is it possible to have one story that just sticks with you, or one technology that has really been a standout for you?
Well, it's kind of like asking me, do I have a favorite child? Because the thing that I really enjoy is the variety of all the projects out here. So I can't say that there was any one. I did mention the MARTI project is really standing out in my mind because it was a really large investment and definitely entered us into a new technology area that we wouldn't have gotten into without it. I would say within the MARTI program, though, I think the ability to use machine vision technology to help enable autonomy has been probably one of the most satisfying areas. One of the technologies that came out of that we call Ranger, and that's using downward-facing cameras on vehicles to look at the driving surface, like pavement or whatever you're on. And it turns out that your driving surface has very much unique footprint, like a fingerprint, so to speak. And that once you've driven a particular path, you can drive that path again very precisely by playing back that where you are with respect to that fingerprint. That was an award-winning technology, an R&D 100 award winner that came out of our internal research program. And it's very much been a part of many of our autonomy platforms ever since.
Yeah, and that's something else to note is we've had many R&D 100 awards, which is known as the Oscar of Innovation in technology and research and development. So a lot of those awards have come from technology that, again, started with internal funding.
Yeah. Another one that kind of comes to mind out of the R&D 100 awards is out of our signal exploitation. It's now called the Defense and Intelligence Systems Division. Defense and Intelligence Solutions Division. And they had a technology that we call Scout, which is a signal gathering type of system. And then that was very successful. And then that led to a unique antenna design and both of those that were worked together were R&D 100 award winners out of internal research.
And they've been featured on the podcast as well. Yes. So, yes, so many strong examples of how our internal funding leads to bigger and better. and again, gets science out of the lab and onto the roads, into our homes, onto our streets. So, okay, so let's get into the details of the program. How are projects chosen to receive funding? Who decides what ideas get the monetary backing? And what are you looking for in a project? So I'm picturing a Shark Tank scenario. We think you have a great idea, but we're out. Or, we're ready to invest.
So funding for internal research, it has many different routes, but the most common route we call through our regular program. So we have regular quarterly calls for proposals of internal research ideas. And so it works very much like our externally funded projects. It's like a client sending out a solicitation for a proposal. And our engineers and scientists here that have an interest in submitting an idea for a internal research project prepare a proposal that includes a technical description of what they plan to do, the cost and the schedule, very much like and it goes through the same systems, if you will, like we develop our externally funded proposals. Those proposals are submitted in a timeline, and they are evaluated by the top scientists and engineers at the Institute, those that have reached the top ring of the science and engineering career ladder, who we call Institute Scientists or Institute Engineers. Now, as a body, we call that group of people the Advisory Committee for Research. And they're the ones that receive the proposals. They divide them up among themselves. They review them very much like an external client would. They score them, and they submit the scores to me. And I look at the top-ranked proposals and decide which ones to fund. Usually there's sort of a clear distinction between those that are really good ideas and those that probably need more work. And we make awards, and we're often running with the projects, and the projects are conducted very much like an externally funded project. So again, it gets back to that aspect of not only coming up with good ideas, but providing very good training for people to conduct externally funded research.
Okay, so a lot of minds coming together to pick the best of the best out of these ideas. And if someone doesn't make it in one round, will the idea pop up again later? Is it possible?
Yes, usually the Advisory Committee for Research will give them guidance. If they think the proposal is salvageable in the future, they will give them guidance of where it needs to be strengthened, or sometimes maybe suggesting adding another division to collaborate. And those multi-divisional collaborations are very effective. So they get guidance and then can resubmit.
Okay, so if not funding, they leave with some valuable advice to make their application a little stronger, maybe for the next go-round.
We hope so.
All right. So what does we've touched on this a bit already, but what does the IR&D program contribute to science and discovery as a whole? While financial gain is important, this is much bigger than that.
Yes. I would say that our internal research program is what helps us bridge the valley of death of technology. Now, when you talk about the valley of death, you're usually referring to running out of money before your idea becomes commercialized. But there's also simply a valley of death because of the focus of science and technology applications. So you have new discoveries coming out of organizations like universities whose purpose is to rewrite the textbooks, to produce peer-reviewed publications of scientific discoveries. And those discoveries lead to potential technologies that can be applied in applications for clients and industry. So their focus is there on the discovery. And our clients, in industry and government, they're focused on their products and services that they have, the current ones and the future ones, and how to make them better, faster, cheaper. And so we're very, very well connected on both ends of those application areas. So when we see a new discovery that we think has the ability to solve a technical problem for one of our clients, we conduct internal research to essentially prove out that concept is really viable. And then we can go to our clients with those good ideas and hopefully get the externally funded work to pursue it. So the contribution to science and technology is bridging that valley of death, being able to go between industry and academia.
All right. And with that, not all ideas turn out to be winners. So what happens when the Institute puts a big chunk of funding toward an idea and it's a dud?
Mm-hmm. Well, that's the nature of discovery. And it's probably interesting to note that often the failures aren't often reported in the literature, so to speak. If you conduct research and you go searching literature about a particular new technology or discovery, if it failed, you won't necessarily find it in the literature. So you actually have to conduct these experiments or these proof of concept demonstrations to find things. So you expect that you're going to fail sometime. And we appreciate the fact that by doing it under internal research, we avoid the problem of having to tell a client, disappoint a client by saying, we think this will work, and then it doesn't work. And you results in a disappointed client, which is really unfortunate. And I think the most common thing that happens here is that people tend to think that ideas will scale well. Something that works well in the laboratory will work very well or equally well at the industrial scale. And that's simply not the case. If you are going orders of magnitude of improvement in a particular technology, sometimes you just reach a brick wall and it doesn't work anymore. And that's typically the nature of the sort of failures that we see, ideas that don't scale well.
So this is really, as we mentioned, a forward-looking program. You're kind of looking into the future and trying to guess or think about what is going to be big further down the road. So how does that work? Your scientists and engineers are coming to you with these, again, unproven concepts, but it really is part of the forward-looking process, looking into a crystal ball.
Well, again, it's a twofold type thing. One is you have to be connected on the research side, the basic research side. That's where it's important to participate in professional societies or conferences where new technologies are published and discussed and presented. So you have to be aware of that. And then on the client end, you have to be well connected to know where they're going, what their needs are. And it occurs in a variety of ways. Like in many of our government-related programs, our clients often put together roadmaps of where they need to go. And that allows us to see and then think about the technologies that might help them get there. On the other hand, some of our work's regulatory driven, like particularly our automotive areas where you're looking at emissions reductions or fuel economy improvement. And our regulatory agencies provide us clear guidelines of where our customers are going to need to be in the future. And there's many different technology paths that you can take to get there. And so those are the sorts of things that give us an idea or an indication of what we need to be looking at, and those are things that make the ideas arise for the internal research projects.
So what type of feedback do you get from the scientists and engineers participating in the program? How does it inspire them?
The feedback I get, the most gratifying feedback, is when I get a note from a project manager saying, I got this project and it was due in part, at least, to internal research. I make it a practice of sending notes to new project managers when they receive an externally funded project to congratulate them on it. And that kind of gives them a natural course to be able to reply to me saying, hey, yeah, and I appreciate the internal research that enabled me to get this work. And then, of course, the one on the staff renewal side, that people appreciate the opportunity to participate in activities that they wouldn't otherwise have the opportunity to pursue.
And on the flip side of that, what are you hearing from the clients who benefit from these well-researched, well-developed technologies that sprout from the program?
Well, I think the most sincere form of gratitude that we get from our clients is when they give us a project and say that they would then trust us with their precious funds to do the work for them. And the other aspect of it, I think, where the clients appreciate is when we use internal research to do development that's related to some of our consortium activities, where they know we're in it with them, investing some of our own funds side by side with them to essentially develop this new technology area.
All right. So a lot of good happening for our scientists, engineers, and also our clients. So there is really feels like a win-win a lot of times. Even when there are those failures, I imagine that learning that something doesn't work is sometimes just as valuable as learning what does.
That's a good point. And I've always said that one of the things we strive for at Southwest Research Institute is a win-win-win scenario. Our clients need to win, our staff need to win in terms of professional development and working in new technologies, and the Institute needs to win. We exist on the contract research that we perform for clients in government and industry. So when you can achieve all of those things where the client gets what they asked for in the way of their solicitation and the staff gets to advance their capability and we are able to stay in business and invest in new technology for the future, then that's a win all the way around.
Win, win, win. I like that, adding that extra win in there. Okay, so what do you think our visionary founder, Tom Slick, would think of this program? Does this fit with what he saw for the Institute?
Well, I think considering that the R&D program is a great source of innovation, I would imagine that he would like it very much.
He was also very forward-looking, always thinking ahead, wanting to invest in science and research for humanity, and that's so much of what this program accomplishes.
Exactly. But you remember, it was his vision to found this organization, but it was also his intent that he would not have to support it financially forever, that it would become self-supporting. And I think the internal research is a very important aspect of that, of helping the Institute be self-supporting through the contract research that we perform for clients in industry and government. We don't exist on the basis of a large endowment, gifts, donations, that sort of thing. It's all funded by the externally funded contract research.
Government and industry clients.
Yes.
Okay, so I like to get to know the people behind the projects, programs, science, research, and development here at SWRI. So I'd like to talk to you about your journey to executive leadership at the Institute. So what was your path to becoming executive vice president and COO of this science and engineering hub with more than 3,100 employees and an annual research volume of nearly 844 million? You have a big job, Walt.
It's fun, too. So I'm a native San Antonian, but I went to school in Dallas at SMU, and that's where I got my engineering degree. And I took my first job out of SMU in Houston. I worked for Brown & Root, which is now part of KBR. And after working there for about 5 years in petrochemical instrumentation and controls, I felt like I was kind of at a dead end from a standpoint of you design one plant, you design another, and so you're doing the same thing over and over again. And I also felt a little homesick for San Antonio, and so I started looking for an opportunity. So in April of '79, I joined the Institute as a research engineer in the data systems department. In those days, we were just beginning to apply microprocessors to real-world applications. And so I got into an area of applying microprocessors to testing of electronics. And I was fortunate that the military electronics, particularly avionics, were being managed at Kelly Air Force Base. And they became a client of mine and working in the area of testing of avionics in military applications. When you test things, and this is a key throughout the Institute, you learn a lot about how those things work. And that naturally leads into developing those particular things, avionics, for example. Because when you provide added value to a client, when you're testing something and it fails, if you can tell the client what's wrong and how you can fix it, it's a natural entry into research. So I very shortly after becoming the Institute in 1981, I became a section manager. And over time, we were able to grow our program. I was promoted to a department director in the late 80s and grew it to a division in the early 90s. And then in 1998, I had the opportunity to become the executive vice president, and it's been in that role ever since, to 1998.
If you told Walt in 1979 that you'd be in this leadership role at the Institute a few decades later, what do you think Walt would have said?
Yeah, we'd be surprised, and it's not necessarily the goal that I had in mind way back when. It developed over time, and I think it's largely because you have the opportunity to find a technology area that interests you, and if you've got a client base for that particular technology, then you're able to build a program successfully. And so that's the key thing, I think, is finding something that you really enjoy doing. I'm involved in professional societies that are related to still related to the activity that I enjoyed doing, and then it's a very natural thing then. What you're doing for work is very similar to what you're interested in doing as a professional, and that's the guidance I would give.
And over the span of this time, you've seen the explosion of technology that the Institute has its hands in. So your thoughts on just, where you started, where we were, and where we are now.
Yeah, I mean, think about it. When I started the Institute in 1979, we did not have personal computers. We were still existing on electric typewriters and that sort of thing. So it was before the internet age. it's really amazing. And I would encourage anybody to look at a technology timeline and compare it against your age, and you'd be surprised how many things have developed over the course of your lifetime, whatever your age is. It's really amazing.
And how easily we adapt to using it all as if we've always had it. Okay, so you've given us some great advice, but what would you tell people early in their careers hoping to be in executive leadership one day?
I would say get involved in professional society, attend the meetings of that society, get involved in the leadership of those societies, because what's going to happen is you're going to get to be known as a player in that particular technical community, and it'll help you grow. And continue to be curious, continue to learn, take advantage of the opportunities that you have to develop your profession, and again, find something that you really love doing.
All right, really strong advice from the man who knows. So what do you want the world to know about our institute, about Southwest Research Institute?
We conduct advanced science and technology development to solve difficult technical problems in applications ranging from deep sea to deep space and practically everywhere in between.
To benefit humankind, I love that about our institute, is we're always looking to solve problems that can help everyone. The SWRI-funded Internal Research and Development Program is part of what advances groundbreaking discoveries and world-changing ideas at the Institute. If you want to learn more about the program, visit ird.swri.org and read the Technology Today magazine Spring 2024 issue. Both resources will be linked on this episode page. Again, thank you, Walt, for this inspiring and insightful discussion. SWRI's IR&D program is a strength for the Institute and give scientists and engineers the tools they need for progress, again, that benefits humankind.
Thanks, Lisa. It was a great pleasure to be here today. I enjoyed talking with you.
And thank you to our listeners for learning along with us today. You can hear all Technology Today episodes and see photos and complete transcripts at podcast.swri.org. Remember to share our podcast and subscribe on your favorite podcast platform. Want to see what else we're up to? Connect with Southwest Research Institute on Facebook, Instagram, X, LinkedIn, and YouTube. Check out the Technology Today magazine at technologytoday.swri.org. And now is a great time to become an SWRI problem solver. Visit our career page at swri.jobs. Ian McKinney and Brian Ortiz are the podcast audio engineers and editors. I am producer and host Lisa Pena. Thanks for listening.